Welcome back to the Powerhouse with your mathematical meathead himself, this guy here. So, what are we talking about today? Oh, that's right, we're talking about the surface area of 3D shapes. We talked about area, we did 2D area, we did squares before, we've done triangles, we've done circles. The next logical step is to talk about surface area. Surface area is at its very core, adding up the 2D areas of a bunch of different shapes. The surface area specifically is when you take apart a 3D object and break it down into its component shapes. Let me demonstrate, actually with a neat little animation, courtesy of GeoGebra and a few other online resources here, right? What you'll see a lot are prisms, or at least what we'll be working with, prisms, pyramids, and I'll even throw a cylinder in there just for funs. Okay, so let's look here. Let's visualize. You have to visualize the geometry net happening, right? You have to envision unfolding a 3D shape into its component 2D shapes. So that way you can perform area calculations and then therefore add them all up together, get an answer. What we have here, rectangular prism, or actually this looks more like a cube to me, but it's labeled as rectangular prism, but essentially, look. All right, let's take a look at what it is. Okay, like look, I can, it's you can see it's a cube. It is a cube, right? It looks like a cube, right? A geometry net is mentally, visually unfolding, and there you go. There you go. Look at that. Look at that. Look at that. There you go. Unfolding it to its component shapes, right? It looks like a cube. And now, boom, we have its component shapes, right? We have a square, 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 lots of squares, right? They all look the same. I can do a calculation on one square and I can see 1, 2, 3, 4, 5, 6 squares. So find the area of one square times 6, boom, surface area. Okay, so that's kind of that. That's, just visualizing this at this point. Okay, so let's go back here. Do another visualization here real quick. Do another visualization. Okay, what do we got? Oh, prism, rectangle. Oh, this is an actual rectangular prism, as a matter of fact. Let's see here. You can see right now it's unfolded, folded up. It looks like just a stick of butter, even I would maybe say, right? A stick of butter, maybe a cereal box, something to that effect. See it rotating here. Can unfold it. Ooh, boom, boom, boom. That's kind of the idea of a geometry net. Okay, boom, component shapes. I see 1, 2 fairly wide rectangles for the main faces. I'll call these the faces. Then you have the skinny one here on the two sides, the skinny sides, and then the tops, right? But essentially, find the area of each unique shape, add them all together, that's your surface area. Here's another one. This one's kind of fun. This one's kind of fun. See, this is kind of like this is a 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. This is a hexagonal yeah, prism. But you can see, ooh, look at that right there. All the sides are the same dimension of shape, right? 1, 2, 3, 4, 5, 6 rectangular shapes, two hexagons. Boom, done deal, right? Find the area of the rectangle, find an area of one of the hexagons, two hexagons times by two, take your rectangle times by 6, add them all together, get a surface area. Get a surface area. There was another neat one I wanted to show you real quick, a cylinder. A cylinder, how it breaks down. That was fairly interesting in that it's kind of cool when you first see it. So let's do I thought I saw a cylinder. Here we go. Here we go. Cylinder right here. Real quick, I'll show you that. All right, there we go. Cylinder. Cylinder is, you can kind of think of it as like maybe a toilet paper roll. That would be one example, kinda sorta. Or even a can of like soup, for example, right? This kind of looks like a can of soup, but if you unfold it, look at that, look at that. Whoa, there you go. It's unfolded. You cut it in half. You can see that the side is a big, huge rectangle. You got two smaller circles, right? Find the area of rectangle, find the area of one circle, times that circle by two. Nice. Done deal. We're not going to work with cones, but this is neat to see anyway. The idea here is get an understanding of mentally breaking down 3D shapes into their component shapes. Once we're there, we can start doing some calculations. Okay, so I'm going to end this here. We'll do some actual calculations here in the next video.